All right, let's take a look at another one. So we've got C6H10. First thing we want to do, calculate the degrees of unsaturation, right? So you can use that equation, or you can think that if this was fully saturated, it would have 14 hydrogens, so it's missing 2 pairs. So there's 2 degrees of unsaturation, right? We only have carbons and hydrogens, so these degrees of unsaturations must be rings or alkenes, right? Can't have any carbonyls or anything like that because we don't have anything other than carbons and hydrogens. Anyways, let's go ahead and take a look at our NMR. We've got this 1H peak over here, and then we've got a 9H peak over here, right? And so both of these are singlets, so they can't be next to each other. The 9H singlet peak, that's one of our common patterns. So if you don't know that common pattern, pause the video and try to find it. All right, so hopefully you were able to figure out that this was the tert-butyl group, right, where we have these 3 methyls all equivalent, right? So we've got that component right there. And then we've just got a single H somewhere. So this is a carbon or an H on a carbon that's then connected to something else, right, 3 times that it's not communicating with, right? It's not coupling with anything, right? And so if we think about how many carbons we've used up so far, we used up 1, 2, 3, 4, 5 carbons, right? Which means that the missing piece is another carbon, right? We have 6 carbons, we've only used up 5, so there's got to be one somewhere in the middle. And so then let's go ahead and connect it to our R groups. So there's that tert-butyl group. And then somewhere else here, we have this C and this H. And so how can we connect just these two so they have no other hydrogens there? It's got to be a triple bond, right, to use up our degrees, our 2 degrees of unsaturation. And so there's the structure of this compound where we have this 9H singlet over here, and then a 1H singlet over here, referring to this alkyne right there.